My name is Craig Lurie, and I am the CTO and co-founder of Keeper. And so I'm excited to talk to everybody. I have a quick deck here, but I'll kind of fly through this because I know this is going to be more of a technical discussion and talking about the product. And I'm a product person, so I like to just dig into that and answer questions and go through that stuff. But just a quick thing about us. We've been around for, since 2011. We're, about 2 million paying customers in our platform. So really we're focused on password security, password management. We have a product for consumers. We started off as a consumer product, and, back when basically iPhone apps were just in the beginning of being created. We were probably the first password manager on the app stores. We're the first to make a paid version, subscription version for consumers. And then we moved upstream to families and then small teams, and there was a groups product. And then eventually we created our enterprise product. And so we sell to everybody, and we have customers all the way from individual users all the way up to very, very large enterprises with hundreds of thousands of employees. So we've got customers all over the spectrum. We are funded by Insight Partners, and I'm in Sacramento with most of our engineers. So most of our engineering team is here in California and spread in a few different states. And Chicago is where our headquarters is, but we're kind of split between Sacramento, Chicago, and then we also have an office in Cork, Ireland, to serve our European customers. We're about to be FedRAMP certified, so we sell into public sector, government. We have FedRAMP environment within AWS. So that's really our focus. So of course, we're in a cyber war, and password related data breaches are a huge deal. So everything from password-based attacks, brute force attacks, password stuffing, platform-based attacks on code is a really huge deal for everybody. And most breaches are due to weak passwords. I mean, everybody probably in this room knows this. So it's not just passwords, it's also infrastructure secrets, AWS access keys, things like that. So breached passwords or weak passwords are really a huge reason for these breaches that we're hearing all about. And so at Keeper, we focus on password management, but we also focus on secrets management, and secrets management can help protect against supply chain attacks and these sorts of attack vectors. And I'll go into that during the demo and answer any questions and talk about those different types of attacks and how we help prevent account takeovers. We are very focused on both password management and also secrets management, which I'll show you, infrastructure management. We're also getting more into infrastructure protection with a recent acquisition of ours and integration of a product called Glyptodon, which I'll also show you. But it gets into not just humans managing passwords and protecting those accounts, but also machines. How do machines authenticate? How do they get the information they need to securely access and communicate into databases or other cloud services and things like that? And so our software helps protect against that. And we're keepersecurity.com. I'll jump into the product side of things. So I've got a bunch of stuff that I'll show them on a Mac, obviously, and I have an iPhone app here that we can jump into the mobile stuff, but I kind of jump around between platforms. Before we go into like the actual product itself, I like to talk about our encryption. We spend a lot of time on this. It's core to what we do. So, and this is all public, by the way. So if you go to docs.keeper.io, you can read about our security model, our encryption model. So Keeper, our platform, is what we call a zero knowledge and zero trust architecture. You hear a lot about zero trust, but really with our platform, zero knowledge is critical. And what zero knowledge means is that all of the encryption and the decryption of data, so everything that's in your vault, your passwords, secrets, whatever, files, everything that's stored in your vault is encrypted locally on the device. So we at Keeper, we're a cloud-based service. We have infrastructure in AWS and different data centers around the world. We're only storing the ciphertext for customers. So the information is decrypted on the device locally. And what that means is, we use 256-bit AES. We also use elliptic curve encryption. And I'll kind of go into the different ways that we do that. But bottom line is that the encryption is happening on the device. So a lot of people ask, well, how is it usable? And, how do you have multiple devices and all that? So there's a lot of work that we do to make sure that, the information is synchronized between devices, that you're able to access your passwords everywhere, and that we can't access them. And so really bottom line is everything that we develop and everything that we create is zero knowledge, meaning that it's zero knowledge from us. We can't decrypt our customers' data. And it's also zero knowledge between users. Even in an enterprise environment, you're the admin, you're deploying Keeper to your users. You simply don't have the ability to decrypt like your CEO's vault or your coworkers. You can't decrypt each other's data. So it's kept zero knowledge from us and from the provider and between users. So we have this concept of record level encryption. So that means that, if you have, in this example, 10,000 records in your Keeper vault, it also has 10,000 AES keys protecting your data. So we have this multi-layer encryption where it's each individual record is encrypted, and those are encrypted again by what we call the data key. Every user has a data key. Those data keys are encrypted by another key, which can be a key derived from the user's typed master password, or in the case of users who are deploying through a single sign-on, like Azure or Okta, anything like that, we have a different mechanism of encryption. And so I won't get into all the details here, but again, if you have questions and you want to read about it, you can go to this site. A couple of things just to kind of go to talk about is first of all, how the encryption model around how to protect data in a vault through typing a password. And so this applies mainly to, let's say, consumers that are using the product, like individuals, or if you're an admin that's deploying Keeper, or you don't have a single sign-on like Azure or Okta, and you just want to use the vault kind of to access the vault. You want to use a password or you want to use a biometric. This kind of shows how that works. And the way that it works is that when you type in the password to access your vault, with traditional products, like that would be like sent to the server and the server validates it. Well, we don't do that. When you type it in locally on your device, it derives a key using PBKDF2, which is a hash derivation function. It derives a key from that, and that key is used to then decrypt the package of information that's local on your device, which then unwraps your individual record keys and folder keys, which then unwraps the individual records that are stored in the vault. And so it's multiple layers of decryption that happens on your device. And then simultaneous to that, it synchronizes with the cloud. So it authenticates with the cloud. The cloud pulls down the ciphertext of your information. It merges it locally. It updates things that need to be updated, and then decrypts the data locally. In addition to that, there's what we call device approval. And you'll see if you play around with our product and you see how it works, you'll see that we have a pretty cool device approval system, which basically makes sure that you can't even attempt to authenticate until your device is approved. So if it's an unrecognized device, you'll have to approve it. You can approve it through a prompt, through a push, through an email. You get to kind of choose how you want to do it. But you can't even attempt to log in. So we protect against brute force attacks, enumeration attacks, things like that in our platform. And then once you pass that device verification step, then you may be prompted for 2FA if you have that set up, which we encourage, of course. And that 2FA could be through like a hardware-based YubiKey WebAuthn device, or it can be TOTP or other methods like Duo, RSA, things like that. So there's multiple levels that you have to go through to authenticate. And once you do, then you can decrypt your vault. We also support biometrics. And so Face ID, Touch ID on the Mac, and Windows Hello on Windows. So we also support those. We call that a biometric key. And so in that case, a a locally derived encryption key is created. It's stored in the biometric enclave of the device. So for iOS, let's say it'll store it in the keychain. And then when the user uses Face ID to unlock their device, it pulls the biometric key and it uses that to unwrap the data instead of using that master password derived key. So you'll see that when we go through the product, but it's good to kind of go through this. We also have a different method of encryption that we use for customers who roll out our product using a single sign-on. Now, this is really important because we call this SSO Connect. And, you know, a lot of enterprises use a single sign-on. Typically, what we see is Azure is like the number one. You see Okta, there's like Ping, there's like a ton of different identity providers. And there's also like, if anybody has like on-prem AD still, they may be using ADFS, but most customers are starting to use Azure. And so in that model, you know, customers, you want to deploy applications to your users with your existing identity provider. And to do that, we wanted to make it really easy. We wanted to so that you can sign into your vault with your identity provider. But how do you do that and preserve zero knowledge? It's really difficult. So we have a mechanism for doing that, and we call it SSO Connect Cloud. And the way that it works is that when you log into your vault, it routes you to your identity provider. So it could be like Azure, and I'll demonstrate this as well. Azure, Okta, or any of those, any SAML 2.0 identity provider. After you authenticate with your IDP, that signed attestation comes back from the IDP, presents it to Keeper, and we say, okay, yeah, you are who you say you are. And then at that point, we do a device approval. We push the ciphertext to the user's device, and then the user has to decrypt that data. So to decrypt that data, we use elliptic curve crypto. So anybody who's pushing out SSO with Keeper, or I should say Keeper with an SSO product, every device that they launch it on generates a locally derived elliptic curve key pair, public-private key. The private key stays on the device, the public key is on the server. And after the user is successfully authenticated with the identity provider, it loads the ciphertext onto the device, and then the device is able to decrypt locally using that elliptic curve private key. And then people, probably going to ask, like, how does it get the key and how does it get encrypted? Well, we have this device approval system, which we call it, and it's a key exchange system that the customer hosts, and it allows the customer's environment to push the encryption keys to the user's device, and therefore allows them to decrypt their data. So we have a mechanism for that, and it keeps us zero knowledge, so we still can't decrypt the data, and it keeps it really easy for the user. So the end user just signs into Azure or Okta, whatever, and they can instantly access and decrypt their vault on their devices. So it's kind of the same process. After you log in with Azure, it decrypts the data, it then decrypts the folder keys, team keys, record keys, and then decrypts the records in the vault. So this is kind of the overview of our encryption model and how it works. And again, if anybody has questions, feel free to shout out, or I'll just kind of proceed through the demo here and just show you how that works in practice. Now how to deploy our product to users. So you see in password management, there's like a lot of different variations of how people are doing it. With our platform, we cover a lot of the core use cases, and we're multi-platform. So we have a web-based application, which we call the Vault, the Web Vault, and we also have a native desktop app. So we can push out a desktop app to users through Mac, Windows. You can push it out through like any sort of SCCM or systems like that. And then also for Linux. So we have native support for those desktop applications. But most customers, I would say on the enterprise side, typically roll out our browser extension. And then from the browser extension, it kind of leads people into our web-based applications. So we support all the different browsers. And that's this guy over here. So I'll go through kind of the end user experience of what people will see and how you'd use it. And then I'll get into kind of the administration and kind of rollout of what that would look like. So again, we have our native desktop app and our web app. This is our web vault. It's keepersecurity.com/vault for customers that are hosted in different regions. So we support like completely different isolated data centers. We have European data center, we have Australian, and then US, and then also, again, the GovCloud environment in the US. So for public sector customers, they all sort of go to different endpoints. But typically the customer just puts in their email and clicks next, and it'll route through, in this case, I have it set up to route through Azure. So it's kind of cool here where I actually have it set up with a fully passwordless login experience. So I go through my Azure account. I have a hardware YubiKey that's associated with my Azure. So I can just plug that in. It's got a pin. And once I successfully authenticate to Azure, then it sends that ciphertext to the user's device, and then it decrypts that data locally. So this is the end user experience. This is like the happy path experience of what people are going to have happen. And it allows you just to have a really easy deployment to your users. And so what you just saw there is authenticating through Azure, decrypting my data locally on my device, and then giving me access to all my records and passwords. So here on get rid of some of this stuff here. Here on the Vault, there's a few different things here. So you've got information that's private to me, the user, and there's also information that's shared. So for example, here's a folder, business accounts, and it has, some Dell and whatever, Expensify. So this is kind of typical of what you'd see. And then you also have things like shared accounts. So a good example of a shared accounts, I have a shared folder called Amazon AWS, and there's some subfolders like Dev, Production, QA. And then you can see that on the right side, you've got the records, you've got the users who have access. So there's a whole bunch of teams, and there's some individual users with shared access. And these teams can be created. I'll show how to do that in our admin console. So you can create your teams yourself, or you can actually create them directly in your identity provider. So a lot of customers will use Azure groups, and they'll send those groups directly into the team folders.
I'm seeing the work offline option, and it was on the login screen too. Assuming you can't communicate to your IDP or you're offline for whatever reason, what does the workflow look like in terms of authentication and decryption of your local data?
So yeah, let me go ahead and log out, and you'll see that work offline. And so that is important because there's a lot of use cases with the product, and offline access is definitely one of them. So you'll notice that on the login screen, sorry, I have all these windows open, I can't see. On the login screen, there's this work offline. And there's a couple ways this works. And so as a user, you can deploy this into an offline mode. And you see that it goes into offline mode at the top here. And then it asks me for a password. Now, of course, it has to be something like that. It could be a password. It can also be biometric. So I can set up essentially another route into the Vault with a password-based login. So I can type in the password, it derives a key, and then it decrypts the Vault locally. So I'm still in this offline mode. So as an administrator, I can set up a break glass environment for my users, individual users, and they can configure this.
Yeah, and just it's now a bit outdated a couple of minutes ago. When you show that, I'm just curious how you do it in a technical environment. So you also were showing the FIPS level 2 certification. Is there a hardware security module that at the end of the day stores the keys, or do you do this all in software?
Yeah, so it is all in software, but the thing about it is the keys are not stored, and that's really the important part about it. So in our backend, we have encrypted keys. And so the encryption is happening on the user's device. It's encrypting the keys locally. And then in our cloud, we store the encrypted keys. We use FIPS 140. We have a validated module that we use for our backend and our applications. And so it's using that cryptographic module for doing the encryption capabilities, but it's not dependent on any piece of hardware. So the fact that really in terms of the devices, so if you're on a Windows machine and it's got a TPM module and it's integrated with Windows Hello, it'll use that. If you're on iOS, it uses the obviously the iOS keychain. But the fact is that we're not storing the keys, and even on the user's device, it's not storing the keys. They're actually in memory during the session and then destroyed after that.
Yeah, cool that you were getting the certification. So I can remember times when it was really hard to get FIPS level 2 if you had no hardware at all. And yeah, great that Keeper was able to demonstrate and get the certification with a pure software-based solution.
Yeah, thanks. And then, and to answer, it's sort of the same question is that you see here. I'm on a Mac that I'm on. I purposely got this new iMac, which has the Touch ID capability, which is really cool. So it'll use, in this case, it'll use the keychain to store that biometric key, which is generated locally. That biometric key then decrypted my vault locally. And so that's what allowed me to authenticate into the desktop application here. And that allows me also to log in directly without having to route through the identity provider. And it makes use of the hardware of the device. A lot of customers ask us, like, do you have access to the biometrics? And no, we don't have access to your biometrics. This is basically, we generate a key. That key is then using the OS level hardware to store it. And then upon successfully authenticating with a biometric at the OS, that OS provides us back basically with that key, saying, okay, person is verified, they're good, here's the key. And then we use that key to decrypt the vault. And so that's another way of being able to access the vault in an offline scenario. And that does happen, we were just helping a customer yesterday who was using CyberArk for their identity provider. And I guess they had some outage or something. And so people can't log in if their identity provider is down. So you have to have this kind of break glass capability.
A last question to that. Is that always the same key, or do you roll that key over on regular basis?
When you look at the key and the key chaining and all the different things that are encrypted with those keys, for us, rotating the key means just deleting the data. So, for example, if you're concerned about a particular record, let's say this I don't know, whatever this is, Bloomberg. So the key that's used to protect this record, if you want to rotate the key, just delete the record and create a new one. And the reason is that you've got these dependencies and this key chaining, where, for example, this record Bloomberg, I could go in and share it to users. Well, another example, I guess, would be here, like this Amazon AWS folder is shared among users. So what that means is that the folder key for this folder is encrypted with the public key of these teams, or encrypted with the public key of these individual users. So we use elliptic curve crypto public-private key exchange to share information. So if you rotate a key, then you're going to have to go and there's a whole chain of keys. So it's like delete the record, recreate it. Or if you shared something to somebody, you've given them the key at the end of the day. So if you want to rotate the key, delete it. If you want to rotate the key of a folder, kill the folder, create a new folder. So if you leak data to another user through sharing, then you should definitely delete it if you want to remove their access. And the same thing kind of goes for at the user level. So you've got record encryption, then you've got folders, and you've got each user has a data key. Data keys are not shared between users, but the data key could be shared with the enterprise. And I'll show how that works. And that's for particular policy. If you want to be able to transfer a user's vault, if they get terminated or leave the company. But the same thing kind of goes if you're concerned about a data key leaking, then you delete the user, create a new user account.
So in case of a compromise, you pretty much have a different key for each record. So the blast radius is a bit smaller.
Right.
Kind of the only thing that I see problematic my personal entry, I can just delete, create new. That is not a problem. But if you have shared ones and then there are multiple attendees, then the rollover is a bit messy.
Yeah, you know, at the end of the day, you've got sharing of the actual data, right? So let's say this production server I have here that's shared. There's a public-private key, right? So like an SSH key or something, or an SSL key, whatever it is. If you're sharing this to the user, you've shared it to the user, and you know you can update and rotate the contents of this record. Just update it, and that'll update the contents for everybody. You know, but if you've shared that encryption key with them, and then they're able to decrypt that key, they can decrypt the contents. So you've got, you know, authorization around who can actually retrieve those keys, and like you said, it's the blast radius. So our authorization level kind of controls who is able to sync down and retrieve those encrypted keys and decrypt those keys. And then that's controlled at the authorization level. So who you share to, what teams, what users, and so on. And you know, and then there's the contents, and so you can rotate the contents. But yeah, totally. And you know, from a usability standpoint, you know, you wouldn't want you know, a lot of breakage there if you're. But with the blast radius, like you said, that's really the key thing, is that you've got specific folders. Let's say this development secrets is a good example. I may have just my development environment shared in a folder. And so if I'm sharing this development secrets folder to particular users, I don't want any leaked data to kind of expand the radius and what they have access to. So, so we provide that limit in terms of scope so that only those users can decrypt physically the records that are stored within that folder. And that kind of leads into the applications as well. So we can assign applications to folders. And this gets into our secrets management capabilities. But for example, you may want Jenkins or this is, I guess this is the Jenkins pipeline I've got assigned to it. So you can assign very specific applications who have access to individual records or folders. And this is critical from an infrastructure standpoint. You don't want to give access to some tool like Jenkins is a perfect example. You don't want to give access to more than it needs, only limited access. And so even in a compromised scenario, it's only able to physically request access to and decrypt, and only has the keys to decrypt records that are contained within those specific folders. Looks like there's another question.
To get it right, the access for an automation tool like Jenkins would be you expose an API to that, then Jenkins can tie into to receive the key.
Yeah, so let's go into that. I kind of jumped ahead, but let's since I opened that open the door there, I'll go into it. So that gets into Secrets Manager. So as I showed here in the vault, you have humans that can access it. That's on this users tab. And the way these users access is through sharing of the folder keys. So I take the folder key, it's encrypted with the public key of these users or these teams, and therefore they can log into the vault and they're able to authenticate, decrypt all the data, and do all that stuff. So as a human. For applications, we have a completely different set of APIs. We call it Keeper Secrets Manager. It's on docs.keeper.io, Secrets Manager. And it's a very specific set of APIs and SDKs. And by the way, this is all open source. It's all published on GitHub. So we have, and I'll jump through this. We have a CLI. We have developer SDKs for every platform like Java, Python.net, and so on. And then we have specific integrations that we've built for the various platforms. So like Ansible or Bitbucket or Github Actions is pretty popular, Jenkins, and so on. And so we've built very specific plugins and integrations. But at the end of the day, they're using a dedicated set of APIs that we've developed that you can see in terms of the SDKs themselves, like the Java SDK or whatever. So Jenkins, I think, uses the Java SDK. And so we've built those SDKs specifically and this API for machines. And so it doesn't have the same authentication process and device verification. It's different. It's different because of the use case. And so in the vault, the way that you do it is you go over to your secrets manager and you can see I have a bunch of applications. So this could be an application could be like Jenkins, or it could be just a particular server or a set of servers or a cluster. And an application is made up of devices. So for example, this Azure DevOps pipeline application has access to these 3 folders, and it has a bunch of devices that have been defined. So it's a one-to-many relationship. An application can have multiple devices, and each device has the information it needs in terms of crypto. It has a device identifier. It has a client, what we call the client ID. It has an encryption key that's used to sign the requests that it makes to our server and to authenticate. And it has an encryption key to decrypt the records that have been assigned to that application. So it's very different than what a human would use. It's all just made, for code. And so to create an application, you just click on create application. Application name could be just, demo. And then I would choose which folders I want to access. And so this is where the blast radius, we talk about that. So if I specifically want to be able to only access DevOps secrets folder, I can select that. And I can also lock down access. And so access can be either read-only or can edit. So let's say I want it to be read-only. We also have security in addition to the blast radius and the client, the device identifiers and the encryption keys. We can also lock down access to the API to specific IPs. So the very first time that something requests access, it can be locked down to that external IP address and firewall. So when you generate an application, it goes ahead and creates the first token. So we call it a one-time access token. And you see here in the beginning of the access token, it says US : blah, blah, blah. And so this is basically saying, this is the US data center, and here's the token. And so I can just copy this token, then I can go and use it in that target application. So what's a target application? Well, a target application could be Jenkins, it could be our SDKs, it can be just our CLI. So as an example, I'll use, open up a new window here, and I'll use our CLI. So we have a CLI called KSM, and KSM is our secrets manager CLI. Now, if you're familiar with or if you guys, use HashiCorp Vault or anything like that, you'll be familiar with these CLIs that retrieve secrets. And this is a really cool way to do it. So I can just initialize this. I can just say KSM profile init with the token. I just paste it in. And so now it's been initialized. And now nobody else can use this token. And what that's done is it's now built a set of encryption keys. And I can kind of show you what that looks like. And this will contain a bunch of keys and a bunch of information. It'll contain a client identifier. It's going to contain some private keys, and it's going to contain some information about where to retrieve it. So this information that's stored in this key file is specific to that device, and it's specific to that application. So it's now locally on my environment in my client device, I'm calling it. It has that loaded up, and now I can just say, for example, KSM secret list, and it gives me a list of everything that this client device is capable of retrieving. So what it just did there is it did an API call to our system, pulled down the ciphertext. It authenticated with that client identifier, assigned request, pulled down the ciphertext, decrypted the ciphertext locally, and then provided a list here. So I can just say, just to kind of drill in some more, I can say KSM secret get, and then what we call our UID. So this is a device identifier, or a record identifier. So here's an example of an SSL certificate that's stored in my vault. So you see it retrieve the CSR request and some host parameter and whatever. So the KSM utility is a really cool way to access secrets from the vault. It kind of demonstrates the secrets manager API. And it has some really cool special functionality. So for example, if I want to replace all the variables in a bash script, let's say, with a lookup directly to the vault, we have this special function called KSM exec. So you just say KSM exec and then the system call. So for example, we can use a syntax for, I'll just kind of zoom in a little bit here so it's easy to read. You can specify what we call a keeper template syntax. So keeper : / and then our record identifier, which is it's not a secret, it's a public UID /field /password. So this is saying, give me the password field or give me a particular custom field like a API key out of a record. And then I can use KSM exec with a particular script. And what it'll do is it'll replace all of the environmental variables in that script with direct calls to the vault. And it'll retrieve those secrets from the vault. And in this case, it'll just print them out. So it just echoes a database password. So you can use this KSM utility, not just for accessing secrets through the command line, but also wrapping other functions or other programs. So you can use this for wrapping existing software, replacing hard-coded credentials with lookups directly from the vault. So it's a really interesting way of doing it.
What are the audit and logging capabilities? So, for example, I want to know who has accessed how many times a certain secret that I would like to investigate. Is that easily to find out in your system?
Yeah, absolutely. So there's a couple ways of doing it. I'll show you the user-friendly way here on the GUI. So we call this the Keeper Admin Console. And this is the other side of our product. So we've got like the Vault side, the Secrets Manager side, and then we have the console. And this contains all of the reporting and configuration capabilities. So you see that I logged in with a WebAuthn, and in this case, I'm using a password. This is our, kind of like the root admin. I'm logging into the platform. So this is our admin console, and this has our reporting engine. So just kind of drilling into exactly what you're asking for, I would go to reporting and alerts, and I would go into my reporting system, and I'd want to see all of my events that are related to secrets. And so I can say, okay, give me all Secrets Manager related activities and apply that filter. And so here you see this example that I just ran, which is I was on Secrets Manager, and this device identifier access secrets from a particular application. So the event metadata here is tracked every single action. So every usage from every endpoint, whether it's a human or an application, is tracked within the environment. So you see here, this user here from Java has access from a particular application. So every single access, every user, everything. Now it doesn't disclose secrets in the logs, of course, because this is something that is something you want to be able to export, run alerts, send it to your existing logging systems potentially. So you can see here that under external logging, I have this activated with a local. I have my own Splunk install in my environment, so you can push event data to Splunk. Or an S3 bucket or any other kind of third-party SIM solution like Azure Sentinel.
A very good use case for that is kind of storing one secret on all the developer machines on the local drive and have the SOC on high alert if any time this is accessed, because kind of a, let's say, honeypot credential, that just stays there for alerting purposes.
Yeah, for sure. And so we have, you can use Splunk or whatever for that, but we also have our own alerting engine. I like ours because it allows you to, for example, that's a perfect example what you just said. Like if I have this AWS root login, right, and I want to know any time that is accessed, I can actually set up a webhook and we have some webhook templates, so I can push it directly into Slack. So I can receive an email or an SMS or a Slack push for any particular event that I want to track. So in this case, I tracked any general usage of a particular secret, and like filled, opened, deleted, updated, and then the attributes can be the record identifier. So here I'm actually tracking 3 different record UIDs. And yeah, so you can track particular record activity. You can track any sort of activity, like let's say a policy change. I have one for that. So anybody creates a policy change within the platform, like deleted a user or somebody got onboarded or whatever. So these can be pushed into Slack or Teams channels, so you know what's going on. And this is highly used for sure. And yeah, so the alerting is a big deal, and having full visibility over any sort of either machine or human-based activity around passwords. And that covers everything in the platform, from using the browser extension to using our desktop app to mobile apps, everything. It's all tied together. So yeah, that's a really, really important aspect of it. And then we do have additionally in this console, I'll just kind of go into some of the capabilities here.
Just a second. Could you, before you leave the logging, is there any provision for the offline access to phone home and report back again anything that happened that I did offline when I wasn't connected?
Yeah, it does queue it up. And those are, that's the responsibility of the client device. So all of our devices do queue events. And then when you come back off online, they will send them. In terms of, we do get asked often, like, what if, there's all these what if scenarios, like what if we terminate an employee and then they instantly go offline and then they don't, do all these things. So to combat that, we have role policies. And so one of our role policies is we allow, if there's any concern about access offline, period, you can designate role policies to prevent that. So for example, let's say an administrator, I can go into the admin, we have role-based policies. So I can say for this particular admin role, I can go into account settings and I can restrict offline access. So there's a million bells and switches here in terms of role policies, kind of anything you can think of, we've added. But that's a good example of something where, if someone wants specific privileged accounts to not have offline access for those types of concerns, they can turn that off, and then it just prevents it outright. For other users, yeah, it'll queue them up while they're offline and then send those events later.
Well, since you opened Pandora's box, I'll ask the question about when an employee leaves. I mean, not that anybody quits ever.
Right.
But can you walk through the pain we go through to number one, remove their access, see whether or not they have an offline copy, and then painfully reset the passwords across the board that they had access to?
Yeah, for sure. So we have a few different ways of handling that. What I'll show you is that I'll go into, just to give background here. So this left side here, we call this nodes. And so like a node can be like a division or a region, or it can be an identity provider. I'll just go into that's called Azure AD. So these are users who've been provisioned through Azure. I bring that up because that's kind of the first step, is like an employee leaves and you want to lock their access, right? You can see this user here has been locked. You can do that automatically with Keeper through our provisioning system. So we in this case, you see I'm hooked into Azure and it's using single sign-on with SSO Cloud. This is a typical like SAML configuration. So you can do the SAML setup here. So I've got the SSO for authentication. And then I also have SCIM, and that's a protocol, a push-based protocol, JSON REST protocol that the identity providers all pretty much support now for the most part. And like Azure, what'll happen is you'll go into what's the typical offboarding process? Employee quits or you terminate them. You're going to first, what are you going to do? You're going to go into AD, you're going to go to Azure, wherever you go to disable their access, you disable their access. And what that's going to do is instantly push to us a locking of the account. And so That's typically what our customers do. Is they'll do that. They'll lock the user in Azure. It instantly sends a push to us, and the user is locked in Keeper. And locked meaning that they're instantly unable to log in or access any of their vaults. From there, there's a couple options in terms of how to deal with it.
Well, before we leave there, they have their local client installed on whatever device they have in their physical possession. Does that locking prevent them from going offline?
Well, they're not. Yeah. So if the applicant, that's what I was kind of getting in that scenario. So there's no the application. If the user knows that they're going to get terminated, and they first go offline, and then the admin goes and disables them, there's a race condition there, right? So there's no magic in terms of if somebody's offline, they're not going to receive. Okay. They're not going to receive.
But if they're quitting and they know they're quitting and they access offline first, they've got it. But if they did not do that, then they can't go offline at this point.
Right. Right. And so they'll the moment that they attempt, it's going to lock them down if they're online. But like you said, it's all about what they had access to and what needs to be rotated.
Now I've got to reset all these passwords.
Yeah. So we have this role policy, and I'll just kind of show how that's set up. And let's just say I'm in my node here, and I've got my general users within Azure. We have an enforcement policy called a transfer account. And transfer account policy, in a nutshell, means that when the user signs into Keeper, this is when they're first onboarded. This isn't like after the fact. This is when they're first onboarded to the platform. You set your policies. What it does is it says that when the user signs in, creates their account the first time, it takes their data key and it encrypts it with the enterprise key. And it makes that the enterprise public key. And it makes it so that it kind of holds it in a state where the enterprise admin can use it later for transferring the vault. So here as a role policy, I have assigned the Azure admin as the administrator who can perform account transfers. And then as the Azure admin has special privileges. And one of the privileges under our set of permissions is the ability to transfer accounts. And so this is something that our customers, like when they first set up the environment, they have to set, with encryption, you can't do it after the fact. It's set up front. So this transfer account policy is set up. Users log into their vault, their data key is encrypted with the enterprise public key, and then the enterprise admin can sign into the console and have special capabilities. So for example, if I'm the admin, I can go in, take the user who's been locked, and I can go into now transfer account. And so transfer account gives me as a particular admin or sub-admin or designated admin for these users, I can be given the permission to transfer the account of this user. And so I can choose the destination vault. I'm not going to wreck this vault and do it, but if you go ahead and click transfer, it will transfer the contents of that user's vault. So basically here locally on the console, it decrypts the records from the user. It re-encrypts it with the public key of the destination user, and then it sends it off to the destination user's vault. And so that policy is set up in that way so that, for example, the admin can't transfer the vault of like the CEO. And you can set up very specific chains of commands so that only certain managers can transfer the vaults of their employees and so on. But that's why this policy is zero knowledge from us. It's an instant transfer that takes place here in the console, and then all the alarms go off, and like people get emails and notifications, and so it's kind of a one-way operation. And then once that's done, then you're saying, okay, what do we go through and do in terms of rotating passwords? Well, the user then receives that in their vault, and their vault's going to contain basically a folder that says, transferred from so-and-so. I don't know if I have any here, but it basically receives the vault. It receives a folder that says transferred from Craig, and then they can go in and handle those accounts one by one. They can also run a report within our reporting and alerts module. To answer your question specifically, I can say, I want to know all of the, let's say, general usage, opened records, like anything that user had opened in the past 30 days or at all time. and I can specify, for example, a user ID. And I can say, I just want to track, over here, I want to track like a specific user. And I want to say like what this user has opened in the past X number of days. And so I can run this report. This user only accessed 4 records. I have those specific record IDs. And then I can retrieve those in the vault. I can just search on the IDs. So I can narrow it down so I don't have to necessarily rotate the passwords of everything that they've had access to. I can limit it to, let's say, records that we know for sure that they've opened or accessed on a particular vault.
And how long is that data maintained? So I could actually know in their entire employment they never accessed a password. Yeah,
absolutely. It's maintained from day 0. So we do not destroy logging data, and so we have all logging and reporting and event history from the beginning of time. With this platform, which is pretty cool. And there's also,
so I don't have to change absolutely every password they had access to.
Yeah, I was going to ask the same thing. Like, is there a limit?
I hear that like 5 times to make sure.
Yeah,
you just like reduce my workload.
I know holding on to data is something we should never do, and no matter how much you tell certain companies, it happens. But that was just going to say something like, is there a certain limit to how much data? Like, is there a timeline? Like, I know it doesn't get deleted, but does it get stored? Like, there's a certain cutoff for it.
Yeah, that's a decision you can make, and at the end of the day, like you said, it's about the risk and what they had access to, and which are each account's going to have different levels of risk. But you can the nice thing is that you can use the tools to find out what they had access to. Maybe they never even accessed the folder ever, or never even hadn't logged in or hadn't used it or hadn't accessed it. You can also programmatically do this. So one thing, I know we don't have a ton of time left here, but I just jumped in really quickly to our CLI, and we have something called the Commander CLI. It's different than the Secrets Manager CLI. It's very focused on administrative functions, reporting, and so on. So everything that I'm showing you on the UI, you can also do in the CLI. And so, for example, there's a audit report, which is the audit trail. It's got 1 million different filters and capabilities. There's 100 different features of this Commander. The point is that if there's specific things that you want to look at or specific time ranges you care about, you can limit that to this. You can automate the function. You can say every time that an employee leaves, it kicks off this process, generates this report, creates a list. I have to go through the list and now do what I have to do. You could even transfer. You can even do a transfer directly here in Commander. So customers that just are larger tend to like to automate as much as possible. So you don't have to click through everything. You can do that automation here. You can even flag accounts that you need to rotate. So that's kind of the key thing there, is that automation. And then we also, within Commander, we have tools for rotation of passwords and things like that, but that really applies mainly to like service accounts and privileged accounts.
That'd be,
go ahead.
Oh, sorry. So that'd be pretty good. Like, let's say, and it happens, you provision an AD account and they have access to certain folders you could run that audit report, see what they have access to. And this is for an active vault, and then just pull whatever, folders or access at whatever level they shouldn't have.
Right. So there's kind of 2 areas. One is the specific report that shows like each access of a particular record. We also have a compliance report, and it's a little different encryption model. So what a compliance report is, and this is also a really great way to do it, is that let me go back to over here. These reports. So I'll go back to the root. So I can set up a compliance report. And what this does is this has a different encryption model, which gives an auditor, you can get an auditor, could be just a regular admin. An auditor can decrypt record title and record type within everybody's vault. And if you assign this, then what happens is that, for example, this ADT control. So if you want to know who has access to like the employee, ADT system, or this is the alarm system, whatever. this record title is encrypted with the auditor's public key, as well as the type. I didn't get into type, but type could be anything from, here's all the different types, like databases, servers, logins, whatever. So you have different types of content. So these types get encrypted with the public key of the auditor. The auditor could go into and run this report. The point is that you can actually search if you're concerned about, let's say, Azure logins, or you're concerned about specific privileged accounts. You can search for those, the existence of those in the vaults. You can find out who had access to it, how they gained access. And for example, here's a Chase business account. Who had access to it? What was their permission level? And how did they gain access? It was through a shared folder or things like that. So these compliance reports allow you to also, in a different way, run a different kind of report where you can search across everybody's vault and understand not the secrets, but just the content, is it, title and type, basically.
I was going to ask, and I think you answered some with the rotation stuff, but first of all, this is pretty slick. I think this is kind of cool.
Yeah.
This is the first time I've gotten excited about a password manager in a long time.
I wish I had this 2 years ago.
So I guess my question too is, to the extent that you can use combinations of rotations for brokered access, and is it possible to do SSH keys with this as well?
Yeah, so I love SSH keys. So a good example of that is this. So I've got a folder called Connection Manager Secrets. This is like an embedded SSH key into a field. And then I have another example of using just a PEM file just attached as a file. And so it's kind of two styles of storing SSH keys. So these can be used if you want to actually use them for SSHing directly into a server, or they can just be shared among a team or just stored in the vault. So there's use cases for both. For example, we have this product called, I think I mentioned in the beginning, the Scripted-on product. So if I want to directly access an instance with an SSH key, I can do that like I did right here. And so I can directly access into a Linux server or Windows machine using an SSH key that's stored in the vault. So it's a direct link, and it makes it really easy for people to, provide privileged access to these sessions. And so this applies to both, any environment, basically, any Linux-based environment. You can install this, but like I said, you can use it, just use it directly in the vault, however you want to use it. We have an SSH key type here, SSH key type, that has some required fields, passphrase, whatever. So you can make use of our specific type, and then you can even go one step further, and you can use them for direct access through a browser by installing our gateway. And it allows you to create these privileged sessions without having to provide a user directly with the access key. So, and it's even audited. So if I wanted to see, this is just me a few seconds ago, if I wanted to see this session, I can replay it.
Do you can also launch your favorite SSH application directly from here?
Commander has a use case. We have this, it's called Connect. It's called SSH. So you can do a direct. So if I want, I don't have one probably I can use, but if I wanted to SSH straight into a particular record, I can do that. It's not going to work. I just chose something randomly. But to your question, you can directly SSH through a native client. But what I was showing here is a privilege session where you hide the SSH key. You're not actually giving it to the user. You're just giving them a web-based connection to it.
No, where I was referring to the admin community, everybody has his different favorite SSH client, and comes in. I'm searching for a method to provide them the keys, in a best usability way where they don't have to worry about. Okay.
Yep. So it's you have this use case here where it's basically I'm in my vault. I guess I didn't really, so like here's my vault. I can search for, SSH. It's a command line interface to the vault, and it's literally using SSH on the system. It's no different than just saying, it's just conveniently allowing you to SSH without having to type all the command line parameters. But to your question, we're building that. That's actually kind of like in the next phase of what we're working on. So we have the browser interface, which is super. I mean, you say that people like to use their own tools. I agree with that. However, you got to test this because it's really cool. It's extremely responsive, and there's almost no difference between using this and using a native terminal.
Glad to hear that you're working already on it. Yeah.
Yep. So there's going to be an opportunity to do that. So that's coming soon. But yeah, we hear that a lot. There's, people want to use their own tools. I get it. But you also want to be able to potentially join sessions. That's one of the cool capabilities of this platform, is that you can actually have multiple people on the same SSH session. You can join them. You can interact together. You can jump between sessions. You can record them. You can audit them.
Pointing at me. Does that mean I can ask my question?
Get the last question.
Okay. Oh, but what if it's a rubbish question? Okay. Really quick question, actually.
Yeah.
Probably yes or no. But user-wise, if I had like, I get the role-based access, but I'm actually more thinking of if I have like a contractor, for example, and maybe I don't want to give them a full account, can I share outside of this? Or is it you would create them a special account?
Good.
Yeah. So yeah. We have, we're about 1 to 2 weeks from going live with a new feature called one-time shares. And it's, you can go into your vault and you can share a record, very similar to what I did with Secrets Manager. And I could probably show that in a few minutes if I kind of stop sharing my screen and grab the info, but it's going to go live in a few days. And you'll be able, so basically it says records, users, applications, and then there's one-time share links. So you can assign these one-time share links to a record. I can give someone, let's say, access to a Wi-Fi password to a contractor. They access it on their device. It locks down their browser or their device that they accessed it on. They don't have to have a keeper user account. And it uses our Secrets Manager API, which is really cool. And it locks down that device to that record.
I love that. That is the excellent way to just kind of tell people, stay tuned for more info.
Love it.
I normally have kind of I can show after this in a few minutes break, I can pull it up and show you guys in our dev environment. But it's really cool. It's called one-time share and it's happening.